record. Cool. All right, so we're going to talk about the EMT bending, and EMT stands for electrical metallic tubing. Okay, we're going to talk about bending that EMT, and today we're going to concentrate on something that's called the offset band. In the previous lecture, I presented to you different types of basic bands. Now, when it comes to pipe bending, we're not limited to just those basic bands, but we got to start somewhere, right? And basic bands is the one that I showed you last time. And today we're going to concentrate on something that's called the offset. What is an offset? An offset is that the pipe is running straight for some time, for some distance, and well, the planes of traveling change, so we have to accommodate that. So we have to step it up, and we're going to have to bend the pipe in a way that things look good, things look nice, things look professional. All right. And if you have to bend 2 or 3 of those beside each other, they're not going to look different. It's going to look nice and beautiful as it came out of a factory. All right. Okay. So what can we see here? Now I got this thing from the internet, this picture, somebody, and here's the reference for the website I got it from. I don't want to steal anybody's work, so I'm required to provide a reference. There we go. I'm happy to do that. So go and visit that site and give them the credit that they deserve. I heard it somewhere. All right. Anyways, so if you see that there's a light casting a shadow, and what do we see here? It looks like a right angle here, doesn't it? All right. So here's the angle that we're bending the pipe from one side. And then if you continue on a straight line, that's going to be the same angle right here. So we are bending that thing, and that looks like a 30-degree bend. So it looks like it's 30 degrees here. And if you draw a straight line, you're going to have a 30 degrees here. So you bend it out of its alignment. And then when you reach the top of your, stair here, the step up thing, you have to bend it back the same amount. So this line here is parallel to that line. Also, what's going to happen, because of that bend, the overall length, okay, go back. The conduit or the pipe is going to shrink. What does it mean that the pipe is going to shrink? Is the pipe made out of rubber? No, it is not made out of rubber. So if you shrunk yourself to a little tiny person like that, and you walked into that pipe, if you walked from one end to the other, you would still cover the same distance. But the overall length, if you're looking from the top, that piece here is going to retract a little bit because of the bend that we have just done. And that retraction is called a shrink. So it's not the length, the linear length of the pipe. That's not going to change. But if you look at from the top, and if you look at the shadow casted, the shadow of that is going to be a little bit shorter. So that's also important when we're talking about pipe bending. All right. So let's transfer that into something. Okay. Well, you know what? Before that, I have a little table to which we are going to come back. All right. Now, do I have the, let's see, where's the shoe? Here is the shoe of the pipe bender. And I'm just, give me a couple seconds. I'm going to rotate that so it kind of looks less awkward because it looks like it's upside down. Rotate view clockwise, rotate view again clockwise. Now we have those angle markings. Here's a line and it says 10, so that's a 10 degrees. Here's a line that says 22 degrees. It's actually 22 and a half. And here's 30, 45, and 60. You can also bend the pipe to a 90 degrees angle, but we're not using any of those markings. We're doing a little bit of a different technique when we're just bending at the right angle. So you can use a level for that too. Excuse me. So And over here you have the hook. So basically what you do is you put the pipe right into that hook. Here's that little cradle that's going to hold, the hook is going to hold the pipe, and it's going to lay in that cradle. And if you bend the pipe this way and you make the pipe parallel with this line, you have bent the pipe 10 degrees. If you make the pipe parallel with this line, you have bent 22.5 degrees, and so on. Right? So here are the degree markings. So what do we have? 10 degrees, 22.5, 30, 45, and 60. Why is it 22.5? Why do we even have that 22? What's that? What's that about? Why not 23? Why not 27? Well, 22.5, if you multiply it by 2, it gives you 90. All right. Sorry. It gives you 45. All right. So if you have the one 3-point saddle, which is basically just to jump over the obstacle, you bend this thing the 90 degrees angle, and then you 45 and 45. You know what, it adds up, okay, because 22.5 plus 22.5, that gives you 45 degrees. And if you bend the middle of the band, if you bend it 45 degrees, so the other bands are going to bend it the other way, halfway, and on the other side, the other halfway. So you're still continuing on the same line. There you go. I got it. All right. Okay. So let me just rotate that thing. So, okay, here 20, 10, 20, I see those. All right. So now, if you look at this table here, that corresponds to those angles, those markings. So here's 10 degrees, 22.5, 30, 45, and 60. And here's that mysterious multiplier, and this is degrees, right? Now, here's the mysterious multiplier, and it has no unit. It's just a number that we're going to use to help us figure some things out, right? I'll tell you what we're going to use that thing for. And here is the shrink. We're going to come back to this table. So I'm going to explain that just a little bit. So you're going to understand it halfway right now. And then once we go through the whole lesson, we're going to come back to the table and look at it again and see how different it's going to look for you, right? So multipliers are different depending on the angle. So you could tell that the multiplier, the only thing that the multiplier depends on is the angle of the band, nothing else. That's how we find out what the multiplier is. And then we have that shrink with the formula for the shrink. But what does the table say? If we bend the pipe 30 degrees for the offset, so we bend it 30 degrees one way, and then at the other side we bend it back again, the pipe is going to shrink 1/4 of an inch per inch of rise. Where is the rise? That is the rise, depending on how high it gets. So this shrink depends on the angle and depends how high do we get with this. So it depends on that line as well here. So the multiplier depends on this angle only, and the shrink depends on the angle and how high do we go. Now, what we need to do is we need to find out where to make those bends, the distance between this mark here and this mark. You can barely see it, but it's there. All right. And once you make those marks, and let me just get this thing here, we'll rotate the view again clockwise and rotate the view here clockwise, and I'm going to find, oops, this mouse here, offset bands, here it is. All right. So first, we're going to bend it out of shape one way using the pipe bender. Let's say 30 degrees. And then we're going to flip it around and align that arrow. We're going to align that where's the arrow? Here it is. That arrow with that other mark. Oops, we're going to flip it around and align that arrow with the other mark and bend it back. So we end up with something like this. And that is going to create an offset. But what we need to do is we need to know the distance between these two marks. Why do we need to know the distance between these two marks? It's because when we bend the pipe out of shape at a certain degree, we need to know how far do we need to travel in this straight line to get to this height. If we make the marks too close to each other, we're not going to clear that height. It's going to go lower. If we make the marks too far, we're going to have the pipe too far. We want to have as precise as we can for professional installations. So we need to know the distance between these two marks. And when we do the pipe bending, 30 degrees, for example, and we bend it one way and we bend it, so we're going to have two parallel sides here, and we're going to have the travel that is just enough to clear that height. Okay, so we're going to come back to this table here. Let's look at the right angle because that's what we have. See that? We got the right angle. Pictures don't lie. Well, they do sometimes. So here's the trigonometric functions of and their reciprocals. Okay, so let's take a look at the right angle triangle. Here's the right angle triangle. So here is how high we're going to get with this one, the opposite to this angle, because we're talking about the pipe is going to be bent that much with the angle of theta. And of course, from the math classes, you know that if we're talking about this angle right here, so this line is going to be adjacent, this line is going to be opposite, and this line is going to be the hypotenuse. So here's the right angle, and here's the theta, and I just put the letters corresponding to the all for the opposite and so on. And you probably remember this SOHCAHTOA thing. And the SOHCAHTOA thing is that sine trigonometric functions we calculate by dividing the length of the opposite to the length of the hypotenuse. All right, so we get the sine of this angle by dividing this length into that length, and the cosine is going to be adjacent to the hypotenuse, so this and that, and the tangent we're going to get from opposite to the adjacent, and we're going to get some sort of a number, right? And the number that is sine, it has no unit. It just depends on the angle. All right, so let's take a look at the functions and the reciprocals. Here's the function sine of the angle theta, which we just called it theta. We can call it whatever we want, but we're just going to call it theta right now for purpose of simplicity. So the opposite and over the hypotenuse is the sine. Now, if we flip things around, instead of opposite to hypotenuse, we're going to go put this on top and this on the bottom, which would be hypotenuse over the opposite. We're going to go get something that's called a cosecant, which is the reciprocal to sine. Right? We just flip it around. Cosecant is the inverse of the sine. And the other ones go with the cosine, and there's a secant, and then there's a tangent, and there's a cotangent. So these are the rest of the subgroup. But we're going to, for the purpose of our pipe bending and calculating something that's called the mysterious multiplier, we're going to concentrate on this sine and the cosecant. Now, you could just calculate the cosecant. Let's say I have the scientific calculator here on the Windows 10. And if you look at, let's say 30 degrees, and if you go to trigonometry here, can you get the cosecant? Yeah, here it is. And it's going to give you the number, it's 2. But sometimes some calculators don't have that. They just have the basic trigonometric functions. So in order to get the cosecant, we're just going to calculate the sine first. So let's say 30 degrees, and this calculator works this way. And then, oh, again, my computer wants to update. Not now, please. Thank you. So let's say 30 degrees, and we're going to get trigonometry. Sine is 0.5, is 1 over 2. So if you flip it around, it's going to get 2 over 1. It's going to be the cosecant, which is going to be 2. So let's see. Here's the function, 1 over x. Flip it. Oh, look at that. The cosecant of 30 degrees is 2. All right. So that's what we're going to concentrate on. The cosecant of this angle. All right. Let's keep going with this. Here is the multiplier. Right. Now we're going to get some little bit more of the terminology happening here. So, all right. So starting from the bend of the angle. So in order to clear the height, we're going to have to bend that angle and travel so far, and then we're going to continue on that once we get there. Right? So the distance between these 2 points, the hypotenuse, it's called a travel. Is a travel distance of the bend. And here, the height, the opposite, that's the offset. And sometimes we call it rise. How much do we have to rise above this bottom line here? And this little thing here, how far the bend lasts is going to be the advance. How far do we advance with the bend? All right. So let's look at, let's take some things, let's analyze some things, let's take them apart. The cosecant of that angle is 1 over sine, which is the hypotenuse over the opposite, right? Cosecant, hypotenuse over the opposite, because sine is the opposite of hypotenuse. Flip it around, hypotenuse over the opposite. So here we got the hypotenuse. Okay, so here's the thing. The cosecant, that number, the cosecant of that angle, which is 1 over sine, is the multiplier. That's it. Lesson done. Go home. Not really, not yet. We're not done yet. Okay. So the multiplier is the cosecant of that angle. Right. Now let's see what I wrote a year ago or so. The multiplier depends only on the angle of the bend. That's how we get, because there's only the angle, that's it. It depends on that. So that's where we get the multiplier. The angle of the bend is chosen by us. Right? So we choose the angle, and then we adjust all the other numbers to the angle that we have chosen. Why do we choose different? Why can't we just have one good angle and stick with it? Well, let me just get this. Here's the picture. All right, here's the obstacle. On the obstacle, here's the offset that we have to make. Now, if we go 30 degrees, this here pipe is going to go this way here. It's going to have certain angle and it's going to continue like that there. Now, if we go less of an angle, not as steep as 30, or more soft angle, let's say it's going to be 22.5 or 10 degrees. Yes, the angle is smoother, but the distance between that, the advance, the distance between this point and that point is greater. And sometimes we have that much distance to cover. We can do it comfortably. And sometimes we work in the spaces that are a little bit tighter. It depends on the situation, right? So, and the steeper the angle is, the closest you're going to get to this point right here. Here's the thing about it, right? When you're pulling, because why do we need to install pipes in the first place for our electrical purposes, right? Well, we're going to install wires inside them, which means we're going to pull wires. We're going to feed the wires here and pull them on the other side. Now, if it's a straight line and the pipe is so long, maybe, I don't know, 20, 30 feet, it is going to give you some resistance already, even if it's just a straight pipe. So some lubricants are being used, and it's a good idea that one person just feeds it just a little bit and the other person pulls it on the other side, and you can get, one cable is no problem, one conductor is no problem. But if you get multiple conductors, then the friction adds up. So the steeper the angle, the harder the pull is going to be. So that's why we choose the angle, and based on the angle chosen, we get the other numbers. Now, just so you know, the 30 degrees angle is pretty much most optimal, and it's probably the most used. Okay. However, can you use 45? Yes. Can you use 60? Yes. Just remember, depending on how many wires you get to pull and what's the overall length of that, some of the pulls might be harder than others. Okay. So let's go back to here. Recap. The cosecant is the multiplier based on the angle that we have chosen to work with. Right? The multiplier is on the angle. The angle of the band is chosen by us. The distance between the bend and the angle is the hypotenuse. So the distance between the bending points. Right here, you have a straight line. If you have a straight pipe, you're going to make a mark here, and you're going to make a mark here, and then once you bend it, that is going to be the distance. So we need to know, before we bend that, we need to know how long this bend is going to be, so we can get to this height if we choose this angle, whatever we choose. Right? So that's the whole science of this thing. All right. If the chosen angle stays constant, yes, it does, the hypotenuse, which is the distance between the bending points, will change depending on the height of the obstacle. Well, the distance, the further you get on this distance, the higher you're going to end up. We need to know exactly, not too far, not too close, exactly where we want that to be based on the height we want to get. Okay. All right. The distance between the bend points is the multiplier times the opposite. How do we get that? All right. From this formula, here's the multiplier, all right, the cosecant, and here's the hypotenuse of the opposite. What we want to know the hypotenuse. That's the one. That's what we want to know, because we know that one. We know the cosecant because of the angle. We know the height. We measured that. We know the height. We don't know the distance. So from this formula, we derive that. So the hypotenuse equals the cosecant times the opposite. So the distance between these 2 points, and this is as simple as it gets. If you remember anything out of this lesson, please remember this. The distance between those 2 points is the multiplier times the height. How do we get the multiplier? It's 1 over sine of this angle. That's the multiplier. How do we know the height? Well, we measure it. Get your tape measure out, measure how high you have to go, and based on that, you have given this, and based on that, you can calculate the distance between those 2 bending points. You mark it here, you mark it there, you bend it one way, flip it around, bend it the other way, and bang, you got the nice, beautiful offset. All right. Okay. We use the multiplier to determine the travel distance, which is basically what I just said, based on the bend angle and the height of the offset or the rise. All right. Again, in other words, the travel distance, the distance between those 2 bend points, is the multiplier times the rise. And that's as simple as that gets. The rise, can you get it in inches? Can you get it in centimeters? Doesn't matter. If you work with one unit, you're going to stick with the other unit. So if you work with centimeters, you're going to have centimeters here. If you work with inches, you're going to have inches here. Okay. All right. So that's it for this slideshow. Now let's take a look at some table. Let's go back to that table here, because what we have here is the table again for a quick reference. Okay. For a quick reference, if you're bending things 30 degrees, the multiplier is 2. So you don't have to get your calculator. You look at the table and the multiplier is 2. All right. And then how much is the pipe going to shrink? How much is the pipe going to shrink? Let's see here. Let me get my board going. Come on. There we go. Here's my board. How much is the pipe going to shrink? So let's say you have a pipe going straight line, and it does have certain distance. If you have that same pipe and you bend it, depending on whichever it is, of course, that distance is going to become shorter because we're going to lose some of the length on the distance. So it's the shrink of the pipe. It's not that it's made out of rubber, it's going to shrink. No, it's the distance between here, the vertical distance right here, from here to there. And sometimes we need to know when they're going to fit the pipes into some sort of a box or whatnot. And yes, sometimes we need to know what the shrink of the pipe is going to be. All right, there. Okay, and shrink amount, how do we calculate the shrink? Now, here is another formula that you're just going to have to remember, or at least know where to find it. The shrink amount is the sine of the angle divided by 1 plus the cosine of the angle. And you're going to get the shrink amount per the distance of rise. In our case, we're going to call it per inch of rise. So if you look at this table, let's say you choose the angle 30 degrees, the multiplier is going to be 2. So now you know the distance between those two marks, those two bands that you're going to make. And how far the pipe is going to retract is going to be 1/4 inch times the distance of rise, the height. So if it's 3 inches, we're going up, then the pipe is going to shrink 3/4 of an inch. Okay. So that's how we look at this table. Where do you have those quick references? Well, I have two things here. I have the KLEIN pipe bender, and I'm not sure if you can see that or not, but there is a sticker here that basically is that table that we're looking at. Then here is the KLEIN. All right. Also, what I have, see what the distance I go for you. Here's the ideal pipe bender, which we have in our school. And there's another sticker right here that tells us, gives us a quick reference. But now you know where those numbers come from. What do these stickers look like? Well, there's that other video that I have, and I just happened to pull it up. Give me a sec here, bear with me. Right here, okay? And wow, one is KLEIN, one is the ideal. Let me just get to the point where that thing is here. Okay, look at that. Right. That's for the offset. So here, if we want to clear, let's say you want to clear, that's how you read those tables on the KLEIN. If you want to clear 3 inches, which means you're rising 3 inches, all right, then it's kind of a little bit different here. The distance between is 6. Based on 3 inches? No, because the 30 degrees angle is going to be a little bit further. Okay, so we want to clear 3 inches. We're going to here. Let's see when I turn this thing. Yeah, I'm just gonna, there you go. I just keep turning that. So here is the 30 degrees. All right. Here's the angles. They put it in the middle of the table. All right. So here's the 30 degrees. And if we want to, we go there and just like clear 3 inches, then the multiplier is going to be 6. There you go. See that? And you see the pipe, and they don't give you per inch of rise. They're giving you the final result. The pipe is going to shrink 3/4 of an inch. So it's a quick reference. That's how you read the table on the KLEIN, the sticker on the KLEIN. Now, here is the sticker. Oops. What did I do? $21, $24. There you go. Here's the sticker on the ideal, on the handle. So let's say we want to clear 3 inches. And here is, you can't see it, but it's above. It's just based on the angle, different angles here. That's how that table is organized. That sticker is organized. We want to clear, we want to use 30 degrees, then the multiplier is, or not the multiplier, we're getting the distance between the 2 points is 6 inches, and the pipe is going to shrink 3/4 of an inch. So it's a quick reference sticker on the KLEIN and sticker on the ideal pipe bender, which we have. Right? Now let's take a quick look at some of the, how do we calculate, let's say 30 inches. All right, multiplier is 2. How do we get the multiplier to be 2? Well, it is the cosecant of the 30 inches. Sorry, 30 degrees. So let's get the calculator here. 30 degrees. 30 degrees, what is the sine? Sine is 0.5, and we flip it around, which is 1 over x, or sometimes, you know, some calculators will have that x in brackets and to the -1, it's the same thing. Click on that. Here is the 2. It's 1 over sine. Sometimes it's easier to remember. It's 1 over sine. Okay, so here we have the multiplier. Right. Now, how many inches do we need to make the mark, the distance between the marks? Okay, that depends on the rise. So if we want to clear 3 inches, we multiply that multiplier by 3 inches. So times 3 equals, wow, magic, it's 6. All right, so here's the thing. 3 inches, 30 degrees, that's, you can see it, but it's there. 6 inches between those 2 marks. The pipe is going to shrink 3/4 of an inch. How do we get that? Well, we get the sine over the angle, which is half, which is 0.5, and we get the cosine. Let's get the step by step here. All right, calculator again. So 30 degrees, trigonometry, sine, it's 0.5. Remember that, okay? So that's the sine, that's going to be on top. What's the cosine? 30 degrees. 30 degrees, trigonometry, cosine, cosine. There you go. 0.866. All right. Well, but we have to add 1 to it. So let's add 1 to it. Plus 1. Okay, so we get 0.87, let's say. All right. So it's going to go, we're going to get the 0.5 divided by 1.0, so 1.87. Okay, well, let's do that. 0.5 divided by, what did we get? 1.87. 1 0.87. That gives us 0.26. Oh, look, it's so close to 0.25. So it's quarter inch. It's very close to quarter, right? 0.1. And there's a way to transfer that. I'll leave that with you. And if you can't figure it out, I will touch on that next time we see each other. So it's quarter inch. Now, quarter inch per inch of rise. So if it is the 3 inches that we're clearing, we're rising 3 inches, we have to multiply it by 3 times 3 equals 0.8, which is pretty much close to 0.75, which is close to 3/4. All right, so the sticker, what does the sticker tell us? Oh, it tells us that the pipe is roughly going to, it's, this is not the, to the millimeter, but to some kind of a close round number. So 3/4 of an inch is a close round number. So we want to clear 3 inches. If we use 30 degrees, we're going to make 6 inches between those two marks, and the overall length of the pipe is going to be 3/4 of an inch shorter, because we're clearing 3 inches and we have 1/4 of an inch per inch of rise. Right? And that's is that all that I wanted to show you here? That's pretty much it. As far as the multiplier and a shrink. So sometimes you might want to watch it a couple times and then and get some of that to sink in. Also, what we're going to do is, when you do your labs and you are finished earlier, don't just drop things and go home. Yeah, I can, you know what, spend some time, use it. I can challenge you. As long as you want to stay, I'll throw things at you to give you more, to give you more, to give you more. Right? Stay over. Get the pipe bender. They're hanging by the stairwells that will go to the upstairs cubicles. Get one of those pipe benders. We have a lot of pipe there. Just grab one of those, cut it to length, and start practicing the bends. Plus, one of the labs, we're going to actually make 2 box offsets, which box offset is an offset, except the end of the pipe is going to be mounted on the box, which is, we're going to rise it 3/8 of an inch. All right. Now there's a question here. Will we have to calculate the shrink on quiz 2 or test 2? Yes, most definitely. And I think by now, if you listen to this lesson, if you watch this lesson, it's going to be on YouTube. And if you still are struggling with that, by all means, talk to us during the lab, me or Mrs. Hashemi, or send us an email. There's nothing wrong. You are paying for this course. You hire us to work for you. And if you have a question, send it to us. We're going to answer that question, unless it's something kind of nothing to do with the topic, then hey, so here it is. All right. Yes, we're going to have to calculate the shrink and the multiplier or the travel distance. Yeah, but I'm going to arrange those questions. I'm going to design those questions based on what we just talked about. All right. Cool. All right, guys. So that's it for this Friday afternoon. And today, I'm not going to say it's almost Friday, because you know what? It is Friday. So please enjoy the weekend. Whatever you have to do, make sure you're enjoying it. Okay. Thank you, guys. Have a great weekend as well. And I will see you next time. As I always say, I will see you when I see you. All right. Bye, guys.